Science and Nature Lore for Preschoolers. I'd like to start by introducing myself. I'm a graduate of Humber College, ECED course. I've had many field placements in the area of Toronto, as well as Kitchener. And I also taught at a summer day camp. All right. Laurie Chambers, Science and Nature Lore for Preschoolers. First, I'd like to introduce myself. I'm a graduate of Humber College in the ECEDH course. I've had a lot of placements in the area of Toronto and Waterloo, and I've also taught summer camp, and this is where I've got most of my knowledge and experience in Science and Nature Lore is at summer camp for 2 years. I was a camp counselor there, specializing in Science and Nature Lore. And during that time, I learned more in those 4 months about science than I had learned previously in all the education that I had, because it was so focused. I had to teach a different activity to several different age groups between the ages of 4 and 10 every day for those 4 months, and it was really challenging. Not the material, because there was a lot of material out there. It wasn't the material that was very challenging as compared to adapting the material to the different age groups, so that you had to make each experiment or activity fit right into each different level that each child was at, each group was at. The focus of this seminar is not especially the material or resources of science and nature lore activities, because there are excellent books out there, excellent sources for you, and we have lists of books that you can find at your library or purchase. We have the publisher's name as well. Some of them are very expensive, but a lot of these are at your local library. And it's not especially the material that we're going to focus on here. We'll give you a lot of examples, and we'll hopefully have time to do a few examples of some science experiments right here in the classroom. But the focus of this seminar is on the teaching methods in relating specifically to preschoolers, children below kindergarten level, or kindergarten and below. Why there is this focus is because there is a lot of material, but it isn't really focused at this age level. And this is where you are really training to teach right now as well. I hope to give you sources for ideas and use samples from these sources to try here in the classroom and focus on the teaching techniques that will make the best of the information that we have. We want to try and create the best learning environment and later to test and see if you've been successful. What I'd like to do is divide the seminar into 2 areas. The first one is the biggest one. It's just teaching science, what the techniques are, and what are the important parts of science that we have to include in order for it to be as great a learning experience as it can be. And the second part is discovering nature and how to make the most of nature in a variety of different ways. Okay, let's start. What is science to a preschooler? What do you think science is? It can be a lot of different things, but just based on your experiences and your placements, or at home with your own children, or just watching children, do you have any examples to give us that shows us what you think science is to a preschooler? Well, young children are natural scientists. They're filled with the mystery of everyday life. things we take for granted, they find fascinating. We often hear them asking every day, why, how, where does it come from? We hear that sometimes so often that we get a little tired of it. And as parents, you can see why if it's 24 hours a day, but teachers, we should capitalize on it. It's not especially what we're going to teach them when they ask these questions, but it's how we're going to direct them or facilitate them to learn about what they want to know. We want them to find the answers on their own, so we have to set up the environment so that they can discover the answers and feel that sense of accomplishment. So often, we all make the mistake of giving answers before necessary. You've been in a situation where you're in a circle or you're teaching children an activity and they just can't seem to hit on the right thing, and you just are biting your tongue trying not to tell them what the answer is. And you know that time-wise, etc., 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 it's a lot easier and faster to just tell them the answer and be done with it. But a lot of times that really can hurt the experiment. That's why when we get into planning, you really have to plan for that. You have to plan for that spontaneity, thinking of things that are way off the wall until you finally get to the right answer, and they come to the right answer on their own. It's really important. Another thing we do, we forget that children are excited about a lot of things we take for granted. Everyday, mundane things like, where does the water go when you flush the toilet? I mean, that might not be very exciting to us, but to a child who watches that water go down and then see clean water come up and has no idea where it's going, it can be fascinating. And that's just a silly example, but why do things grow? Why do I plant a seed and all of a sudden see little things? How did that happen? Why do the hands on the clock move this way? We could all give many examples of the crazy questions we've heard from children, and they're all based on a genuine interest. They're not just asking them for the fun of it or to make you smile, although some children can do that very easily. They really want to know. And just cluing into their questions and finding out where they're at, what level they're at, and what stage they're ready to learn about. That's really being a good teacher. It's being somebody who's sensitive to what the children's needs are and to where their interests are, because it's where their interests are that you're going to lead them. It's through their own interests that you're going to lead them to want to learn more. Science to a preschooler is not based on complicated concepts. Rather, they're based on the basics. They're based on basics that can be witnessed by them and through experiencing through their senses. They have to be tangible. They have to be able to touch them, handle different things, taste, hear, see, smell, using all the five senses to make things real for them. Just seeing pictures or hearing about it in a story or even having somebody do it in front of you. It's not the same thing as being able to do it, really do it, hands-on, making a mess and finding out at the end of the mess that this happens. I mean, that's something that a preschooler really needs. When you get to older children, you can demonstrate a lot of things, and that children will learn from those demonstrations without having to even do them themselves. Something very dangerous that we tend to do is not allowing a child to make mistakes and correct them on their own. When we do planning later on, the importance of planning for this, as I mentioned, will be very obvious. But I can recall my own experiences when I was not allowed to correct myself in the area of math, for example. For years and years, it's been something that I shied away from, totally. Not because I couldn't do it, but I never was allowed to find out if I could do it. I was never allowed to make a lot of mistakes and then go back and start over again. It was, you only had time to make the mistakes, find out you were wrong, and then go on to the next thing, which just was that much more difficult. And here I am, now I run my own business, and I'm in charge of the books, all of the accounts, paying wages, paying bills, which does require a little math skill, not as much as other things, mind you, but I'm doing it fine. I was very scared at the beginning, and I just had to prove to myself that I could do it, and I've made mistakes. But with my own business, I'm allowed to make them, and I'm allowed to correct them as quickly as possible. And of course, you get help from professionals for sure, but it is my responsibility to correct those mistakes and to find out what they are. And that's so important for a child, to be able to make those mistakes and not be just corrected and on. Like, you have to go backwards, do it over again, and then be able to say, I did it, and I know where I went wrong. In our experiments, because we need things in science that are tangible, simple, we have to use, for the most part, simple everyday materials that children have been exposed to previously in their environment, whether at home, around the house, at school, in the yard, whatever. It's important for children to recognize familiar objects and to learn that things can be used differently depending on the situation. If we use a lot of different materials, then the children don't really know that the same things can happen with things that they're more familiar with. They'll only relate the experiment or the activity to those unknown elements. And I think it's really not fair to children to use things that they'll never see any other time, at least not at this stage of their development, not until later, because it's limiting them. They aren't going to expand on it. They're just going to put it away and say, okay, that's for when we only pull this out. You know, an example. I have an experiment in front of me here. It uses a pop bottle, a balloon, vinegar, baking soda, and some cone cups that children either can be familiar with or not, but they're just Dixie cup with looks like ice cream cones. And in this experiment, we're using very basic materials. Now, I could have gone out and gotten a specific type of bottle that, you know, would be perfect for this experiment. Instead of a balloon, I could have gotten, I'm not too sure what I could have gotten instead of a balloon, but instead of vinegar, I could have used sulfuric acid, which would have been a little stupid of me, but I could have used something as unfamiliar as that. Instead of baking soda, I could have used a base powder that was unfamiliar to the children, and done this experiment, and the children would never have been able to be, it would have been something, oh, okay, well, of course those things do that. I've never seen them before. I didn't know they could do anything else. And so if you have this experiment, and I'm going to do this experiment right now, just to show you what I would be doing with the children, we put the baking soda in the bottle, the vinegar in afterwards, pop the balloon on, and the balloon blows up because of the gases created by the mixture of the vinegar and the baking soda and the acid in the base. It's making carbon dioxide. Now, if I had done this with unfamiliar materials, the children would have been very impressed, and yet they couldn't have been as impressed by using familiar things because we're using them in a different way that they're not used to seeing. It just makes them that much more interesting. They can relate it a bit more better to themselves. Alright, when we're teaching science, that's basically what science is to a preschooler. It's just asking questions and finding out, and it's really using things that are very familiar to them, but in different ways so that they can expand their knowledge. We're not trying to give them isolated incidents or activities file away as isolated activities. We want to expand their own knowledge that they have already. They know what vinegar does. It goes on French fries. They know what baking soda does. It goes into cakes. And all of these things, they know something about these materials, but what we're doing is showing them something different, something else that they can add to what they know already. And it's this addition that is science to a preschooler. It is not, and we cannot get into more complicated data or complicated experiments with this age group of children because they don't have these basics to build onto. We have to form the basics first and then start adding on things slowly and steadily. One of the biggest things that we have to remember when teaching preschoolers is in our method, using our method. Scratch that. The next part of this that I wanted to expand a bit on is the scientific method. We hear a lot about the scientific method when we're in elementary school and high school. And I'd like to talk a little bit about it and why it's important. Let's sort of review what the scientific method is. We have the hypothesis, and then the method, the observations, and the conclusions, which lead back to the hypothesis. We hear these terms and we immediately have a flashback to our science classroom where we first learned the meanings of these terms. Hypothesis was a guess or an estimate about a certain idea. We made a guess as to an outcome. And then we tested it with a method. We decided what ways we were going to test it. And then we observed it. We observed what happened. And then we concluded, based on our observations and method, whether or not the hypothesis was correct or not, whether we were correct. For just using this scientific method, can anyone suggest a very simple idea, that we could use with them and just fit in hypothesis and method? For example, things fall down instead of up is a hypothesis. What would be the method? Sure. Having a lot of different objects and holding them up and watching where they go, whether they go down or up. The observations would be observing whether they went down or whether they went up. The conclusions would be, did our observations say that, prove to us that they did go up or down, or and that's okay. Now, why is the scientific method so important, especially when we teach children so young? Why do we have to go into this? I mean, they're not going to understand what a hypothesis is, and they're not really going to know that one thing follows another. Do you have any suggestions why I'm focusing on the scientific method for teaching preschool? Well, it's important to the children very much, and it's also important to you, very much so. First, it's important to you, the teacher, because it sets up the format for you to follow. Entering into an experiment or something scientific where you don't know what the beginning or the end is, and you're sort of starting in the middle, can be very confusing not only to the children but to you as well. It's the scientific method sets up the activity so you never get to the conclusion before going through the other stages first, and it helps you avoid jumping to conclusions before the children get there, and it gives you a structure to work with and a strategy for teaching, so that you can divide and section off your activity and have that much more control. Now, for the children, there's a lot of benefits for the children. for teaching the scientific method. For the first one, is that after a while, after they have had a few activities based on this structure, they gradually come to know and expect the same order. They can predict, and that gives them some control. They know what they're going to do next. And they'll learn slowly but surely and steadily through repetition of that format that their questions are answered, but only after they follow the steps that give them the answers. I don't know if you have ever had this experience, but I set up an experiment, and it had been the very first one that I had ever done with children. It was at a nursery school, and they were not well known for their patience, but this really got out of hand. They wanted to know everything right away. I demonstrated the experiment, and then they wanted to know why, and of course I wanted to go through the whole thing again so that they could find out through the observations and method why this happened. Well, they didn't have much patience, and after children are used to this format, they do start to become a little bit more patient because they know the structure, they're familiar with it, and they know that their questions will be answered. And they don't have to badger you and drive you crazy with asking and not waiting for the end result. It does take a long time. It's not something, children are not naturally patient at this stage, but it does, just because of its predictability, the children can be so sure that the experiment will be the same and that at the end they'll find out what happened. That they can relax a little bit and enjoy the whole activity. Another thing is it gives them a sense of purpose, especially if they're involved themselves in the actual experiment. They know that what they're doing will lead directly to something else happening. They're finding out about cause and effect. A lot of toys on the market now that are very interesting to children are specifically geared to this cause and effect. You press a button, this happens. You press a different button, something different happens. And children at this age are fascinated by that. They love the constancy, and they love the fact that doing one thing will reliably and predictably give them exactly the same thing every time. And when they change it, it will change as well, and it will change. And it just gives them that sense of purpose that they are doing something that directly leads to something else. It also fosters a lot of independence. They have some control over the outcome of the experiment because they're actually involved in it. And learning by doing, they can feel pride in their accomplishment because they are the ones that actually pulled this through. Went from A to B and actually completed the experiment and had a part in it. And they can feel that pride and then they gain independence from that. They're not as scared to try different things. Encouraging spontaneity is another thing the scientific method really helps with, because when you have children in an activity like this, you're encouraging the child's natural curiosity and desire for learning, especially the hypothesis and the method. We're asking the children to guess, and whether they're totally off-the-wall suggestions or whatever, their spontaneity and creativity is what is important at that stage. And you are really encouraging it, and you're ready to try anything just to show them, give them the satisfaction of following through on their suggestions. And it also helps them as well, because it is within a structure. That spontaneity is within that structure. When you're at the preschool level, you're encouraged to be spontaneous, etc., etc. And then when you get to the elementary level, you're asked to be structured. Well, this gives you spontaneity within a structure. So children get the practice of really being creative for the parts that need to be creative, but also following the structure and the format for when they have to follow the method and observations to the conclusion. And it fits very well. It gives them a chance to do both. And I really like that part because I know some children have a lot of trouble getting from daycare to an elementary level, and that they have to be so structured after being so free and spontaneous. And it's a very difficult adjustment to make. And I know some elementary teachers that feel daycare is really lacking in that area because they don't introduce structure early enough, because they don't want to. Understandably, you want children to be children and free as often as long as they can, but it doesn't help them later on at an elementary level when they really can't adjust to the amount of structure at that level. Now, how do we teach using the scientific method? We know why we use it, but how do we teach effectively so that the children will get the most out of our information that we have to give them? I mean, you look at the books out there, and all of a sudden your mind starts going, oh, I can do this and this and this, and the kids will love that and everything else. But if you don't present it properly and you don't think ahead, and that's the big thing about any activity, it's true, let's face it, planning is everything, but in science especially, planning ahead can make your experiment, and not planning can totally make it a disaster and a waste of time. Even though the children will probably get something out of it, they might get something wrong out of it, and then you'd have to actually reteach them, and they would have to relearn that and unlearn what they had learned already, because planning is everything. When we teach the scientific method, it's not important to teach the words hypothesis, method, observations. All of these terms are really for our use, or for another child at an older age. They can understand the words. But if we try and drill these words into the children, we'll only frustrate the children and divert their concentration from the purpose of the activity. Now, the words are interesting, and to expose the children to them would be fine. Every now and then saying the words, is our hypothesis or a guess, and just saying them, and then when the children ask about them, then explaining them as far as you'd like to go, as far as you think they're ready to hear. But to actually drill them into children is really silly at this point. It's not why you want to do science. The method is really important for you. There is one word, however, that worked amazing wonders with children, and that's the word experiment. You don't want to use it incorrectly and talk about an experiment that isn't really an experiment, but when you do use it with children, they can get very excited because they know that it's something special, something fun. And using it for that purpose is really a lot of fun for me. I found it to be so I'm going to do an experiment today. And the kids are, oh, did you hear that? We're going to do an experiment today. And they just really go crazy on doing it. So a lot of fun to see. In the book Sciencing by Sandra Kane and Jack Evans, they elaborate and expand on the scientific method and give coordinating teaching techniques that accompany each stage. And I found these to be very helpful in planning science activities. For example, for the hypothesis, what they use are attention-getting and motivation techniques. For the method stage, they use data gathering. For observations, they use data processing. And for conclusion, they use closure techniques. Now, these are just another set of words in a lot of ways, except that in this book they really expand on each section, which I'm going to do a little bit, just to let you get an idea of how to get the most out of your activity just by directing the activity in a specific direction. For example, for attention-getting and motivation techniques, when you're starting out your activity and you want it to be very successful, You need to get children's attention and motivate them in the direction you want them to go, but you don't want to do it in a way that turns them off. I mean, you can do it, you can say, okay, we're going to do this today, and I want you to do this, this. Well, no thanks. Science is a mystery, and you want to keep that mystery as long as you can, and as interesting as you can, because it's the mystery that makes the kids want to learn. It makes them want to find out what is going on. And maybe you have some suggestions for getting children's attention and motivating them to learn. Great, yeah, sure. A hands-on approach, that's right. So, like, for example, setting out the materials a day beforehand, just to let the children handle them. Of course, they should be definitely non-breakable, non-poisonous. That's something we always assume, well, of course, but really think about it. Really think about every activity you do, especially in science, because you're going to be using some things in some experiments, or even when you're doing nature lore activities, there's going to be things out there that aren't good to touch, aren't good to taste, even some things that are good to smell. And you have to take all of these things into consideration, because I've seen children that, because things happen, they can be very, very cautious from then on trying things just because something happened to them, or they saw somebody hurt themselves, or get sick, or whatever. These are really silly things to mention, perhaps, but they're very important. You want the children to feel safe, but you especially to feel very comfortable with them handling things that you know are safe, that will not hurt them, or with things that might be a little bit, that could be potentially harmful, but not ordinarily so, just to be supervising things very closely. Letting them handle them beforehand, but not knowing what they're going to be used for, and just letting them know that you're going to use them for something very interesting, for an experiment, will sort of start them thinking along those lines, and will really start all of the questions then, at that point, and so they've got a whole day to just come up with outrageous ideas of what they're going to do. Another thing that you could do is use the element of surprise. That's one thing of doing surprises, is letting them use something that they don't know what it's for, but doing something unexpected that just makes them sit up and go, what? What did you do? How did you do that? With things that are very simple, but things that are used in a very different way than they're used to. I have a lot of examples of those. I'd like to do a few. For example, I'll just tell you about them. I have a Kool-Aid can here, and I have a board and some books. I'm going to put the board on the books like this and make it incline. I'm making a hill. Now, which way does the hill go when I point this way? It goes up. I put this way. It goes down. That's right. If I put the can on, which way do you think the can will go? Up or down? I see. And then you totally surprise them by putting the can on and it rolls up. Now, it's very simple to make this happen. On the inside of the can, you have 4 large nails or weights, heavy magnets, whatever, taped onto one side, and you know what side they're on. You could mark the can in the back or whatever. And so that when you put the can on the incline, the weight is all over here, and it's going to make the can roll this way. And just surprising them with something that they don't expect, and makes them automatically go, how did you do it? It can't happen. You do it again, and it happens again. And they really want to know why. And that's what you want to get. You want to get them almost to the point of shock or anger. You might say, you can't do that to me. I already know that the can goes down, and you're doing it so different. Everybody told me things went down. I've seen everything, and I've seen everything go down. It can't go up. And then by doing the experiment, going through it, going through the stages, they can see what makes it go up. And then
High horse woman, I'll make